Title of the next section is Solving Equations. With absolute values. In this section we'll have equations. The equations will have absolute values and we'll solve for the variable. One definition or topic to keep in mind when solving equations with absolute value is to check solutions. Sometimes when solving equations with absolute values, you'll get the correct solution mathematically from the equation, but the answer will not work in the original question. So anytime you get an answer for an absolute value equation, always make sure to check solutions by taking the answer, plugging it back into the original equation, and making sure it works. The first question for the section is the absolute value of x minus 25 equals 17. To solve absolute value equations, we'll end up getting two answers or two equations. The first equation, we can remove the absolute value signs. So we just have x minus 25 equals 17. For a second equation we can solve to get the second answer. Again, we can remove the absolute value signs, which would be x minus 25. But instead of equaling 17, the second equation will equal the opposite, or negative 17. The reason we can use negative 17 is because if the absolute value is equal to negative 17, the absolute value of that would still be 17. Solving the first equation, we can add 25 to both sides, and x equals 42. The second answer, or second equation, again we can add 25 to both sides, and x equals 8. So we have two answers, or two possible answers, x equals 42 and x equals 8. Keep in mind though, we always want to check solutions, especially on absolute value equations. To do that, we can take our first answer, 42. If we plug it back into the original equation, 42 minus 25 would be 17, and the absolute value of 17 is equal to 17. So 42 works as a solution. Our second answer, 8. Plug it back into the original equation. 8 minus 25 would be negative 17. The absolute value of negative 17 is 17. So 8 also works. So the two solutions are 42 and positive 8. Second question for the section is 8 times the absolute value of w minus 7 equals 72. To solve this equation, what we want to do before we write the two separate equations to solve is to isolate or get the absolute value by itself. For this equation, we have to move the 8 to the other side. Since this is 8 times the absolute value, we can divide both sides by 8. That way we're left with just the absolute value on one side, w minus 7, and equals 9. From here, when you have the absolute value equal to a number, to find the two solutions or two possible solutions, we can remove the absolute value signs, which will be w minus 7 equals 9. And for our second equation, again we'll remove the absolute value signs, w minus 7, but instead we'll set that equal to negative 9. And again we use the opposite of the number, negative 9, because when we take the absolute value of negative 9, that would still equal 9. Solving the two equations, we can add 7 to both sides. Our first possible answer, 9 plus 7 is 16. And our second equation, add 7 to both sides. So W is equal to negative 2. Again, we have two answers, or two possible answers for the absolute value equation. Keep in mind these numbers, especially for absolute value equations, you want to plug back to the original question. For example, if we have 16, 16 minus 7 would be 9. The absolute value of 9 is also 9. 9 times 8 is 72, so the first one works. Second possible answer, negative 2. If you plug a negative 2 into the original equation, negative 2 minus 7 is negative 9, and the absolute value of negative 9 is positive 9. Positive 9 times 8 would be 72. So the second solution also works. So again, we have two answers, W equals 16 and W equals negative 2. And the last question for the section, we have the absolute value of 3n plus 2 plus 4 outside the absolute value equals 0. Solving this question, again, the first step is to isolate the absolute value, or get the absolute value by itself, which means we have to move this positive 4 to the opposite side. To do that, we can subtract 4 on both sides. Absolute value of 3n plus 2 would stay the same, and 0 minus 4 would equal negative 4. From here, if you wanted to, you could take off the absolute value, have 3n plus 2, set it equal to two numbers, go through and solve, and then check the solutions. One shortcut on this question, if you look at the equation, we have the absolute value of 3n plus 2 equals negative 4, or equals a negative number. If you think about absolute values, it does not matter what's inside the absolute value. When you take the absolute value, this will be a positive number. It can never equal a negative number or equal negative 4. So in this case, since it's equal to a negative number with the absolute value signs, the answer to this would be no solution. If you did solve this problem out, set it equal to negative 4 and positive 4, you get two answers. Plugging those answers in, neither one would work for the original equation. So again, no solution would be the answer to this question. Title of the first section of notes today is Solving and Graphing. Absolute value. Inequalities. In this section, we'll solve the inequality and graph the absolute value inequality. First problem, absolute value of x is less than or equal to 4. To solve a absolute value inequality, the absolute value again you want isolated by itself, which in this problem it is. And one way to solve this is you can remove the absolute values. So we'll have x less than or equal to 4. And also the inequality less than or equal to, we'll copy exactly as is to the left-hand side of the problem. And the number 4, we'll do the opposite of that, which is negative 4, that we'll put on the left-hand side of the problem. Now we have the inequality negative 4 less than or equal to x less than or equal to positive 4. From here we can graph the absolute value inequality, which again will be a single number line since we have a single variable. We do have two numbers in our solution, so we'll have negative 4 on the inequality, which I'll put on the left hand side, and we'll also have positive 4 on the right hand side. You can fill in some hash marks, so we'll have 0 in the middle. And from here we can graph with the open circles and closed circles. For the negative 4 value, negative 4 is less than or equal to x. Less than or equal to means it will be a closed circle above the negative 4. And for the positive 4, we have x is less than or equal to 4. Less than or equal to means, again, it is solid above the positive 4. So absolute value inequality graphs will have 2 points for the two numbers for the solution. We'll have 2 lines also. Each point can either go left or right, depending on the inequality. If we have negative 4 less than or equal to x, this means negative 4 is smaller than or less than x, or vice versa, x is bigger than or greater than negative 4. Bigger than or greater than would go to the right. Also for the positive 4, we have x is less than or equal to 4. X less than or equal to 4 means smaller than 4, so this will go to the left. When we have the 2 lines pointing towards each other, we can connect them, and the solution for this problem would be the numbers from negative 4 to positive 4, all the numbers in between, including negative 4 and positive 4. Second question and last question for the section. Absolute value of 6a minus 3 is greater than 21. And again, solving absolute value inequalities, the absolute value must be by itself. And to get our inequality so we can graph, we can remove the absolute value, which is 6a minus 3. Greater than 21 stays exactly the same. And again, the greater than symbol will copy to the left-hand side of the expression. And 21 we'll put on the opposite side, but we'll also make it the opposite of 21, which is negative 21. This equation we have to solve. We have to isolate a by itself, 6a minus 3. We can get rid of the minus 3 by adding 3. When you have a compound inequality like this, we'll add 3 to the middle section, we'll add 3 to the right-hand section, and we'll also add 3 to the left-hand section. Negative 21 plus 3 would be negative 18. The inequality stays the same when we add numbers to each side. 6a would stay the same. Negative 3 and plus 3 would cancel. Greater than, inequality stays the same, and 21 plus 3 would be 24. And the last step to solve 6a, to get rid of the 6, we can divide by 6. And again, we'll divide the right hand by 6 and the left hand side by 6. Negative 18 divided by 6 would be negative 3. The inequality stays the same when you divide by a positive number. 6's would cancel. We'll be left with a in the center section is greater than 4. So the solution to the equation or the inequality, negative 3 greater than a, is greater than 4. Last part, we want to graph. Draw the number line. And we want the numbers -3 and +4 on the number line. I'll put -3 on the left-hand side. We'll go up to 0. And we'll continue up to 4. To graph each of these, -3 is greater than a. Greater than means there'll be an open circle above -3. And a is greater than 4. Greater than, again, will be an open circle above 4. For the directions on the line, -3 is greater than a. -3 greater than a means -3 is bigger, a will be smaller, or a is less than -3. Less than -3 would go to the left. And the second part, a is greater than 4. Greater than 4 would go to the right. So in this case we have our two numbers, -3 and +4. The solutions though are all the numbers less than -3 or all the numbers bigger than +4.